By the end of this lesson, you should be able to determine the specific latent heat of vaporization, LV. Solve problems involving specific latent heat of vaporization. If you heat water in a pan, the temperature rises and the water begins to boil. The pan is left on the stove. Will the temperature of the water continue to rise? What happens to the water? If the pan is left on the stove, the water absorbs more and more thermal energy. This will result in more and more of the boiling water changing into steam, but still at 100 degrees Celsius. At boiling point, during the phase change from water to steam, the temperature of the water does not rise. What happens to the heat energy supplied to the water? The heat energy absorbed is used to overcome the force of attraction between molecules. This is called the latent vaporization. Click on the Start button to heat the water until it boils. Describe what is happening between B and C. At B, the water starts to boil. At C, all the boiling water, liquid, has completely converted to steam, gas. During the interval BC, a mixture of liquid and gas exists. At BC, heat absorbed is used to overcome the forces between the molecules to change from water to steam. Replay the animation and observe the arrangement of atoms during the phase change. Note that there is no rise in temperature during the phase change. The heat is removed and the steam is allowed to condense. Observe the temperature time graph. Compare the heating curve and cooling curve. What do you observe? When water changes to steam, the temperature remains constant until all the water is converted to steam and vice versa. The amount of heat required to change from water to steam is the same as the amount of heat released to condense from steam to water. The amount of heat required to convert 1 kilogram of water to steam is defined as the specific latent heat of vaporization of water. The value of the specific latent heat of vaporization can be calculated from the equation LV equals Q over M. The SI unit of the specific latent heat of vaporization is joule per kilogram. The specific latent heat of fusion of ice is 3.34 times 10 to the power of 5 joule per kilogram. The specific latent heat of vaporization of water is 2.26 times 10 to the power of 6 joule per kilogram. Why are the values of these two latent heats different? In latent heat of fusion, the energy is given to the molecules in solid so that they can move more freely as in a liquid. In latent heat of vaporization, large amounts of heat energy is required to separate the water particles far apart to convert it to the gaseous state. An immersion heater supplies heat at a rate of 50 joules per second to an insulated vessel containing a liquid. The liquid is brought to its boiling point and kept boiling for 2 minutes, during which time the mass of the liquid lost is 40 grams. What is the value of the specific latent heat of vaporization of the liquid? Assuming that all the heat supplied by the heater is used to convert 40 grams of the liquid at its boiling point to vapor. Q equals M times LV. Power supplied times time equals to mass times specific latent heat. Therefore, the specific latent heat equals to 50 joule per second times 120 second over 30 grams, which equals 150 joule per gram.